Well, hello everybody and welcome back to another video from the Canal Sidings Model Railway channel. The last video I did was, as many of you will remember, one on how I use JMRI Decoder Pro, and I asked you in that video to comment as to whether you wanted more on JMRI or less. I fully expected it to be pretty even one way or the other. Was I surprised when it turned out that so far I have only had one person say that he doesn't want any more JMRI videos because, quite rightly, he says it's not railway modelling, and it isn't. It's computer controlled railways, which is totally different. Everybody else, and there were probably a dozen more who've actually commented, are all for more information. So, at the risk of upsetting a few people, I will be doing some more JMRI videos. But like I said, I won't be doing one a week. They will come perhaps one every 2 to 3 to 4 weeks. And I'll try to put plenty of modelling videos, or the video I've got today may not be considered modelling, but there you go. I'll try to put more modelling videos in so that everybody gets a little of what they like. The second thing that I want to talk about is, and as you can see, the main thrust of this video is going to be once again about the these servo mounts for point control, or turnout control if you're watching from the States. And you saw me in a previous video, can't remember which number it was, but I'll put a link to it at the end for anybody who didn't see that video. You saw me actually using this, which was the Mark 1 version, which has this, it goes this way round, sitting in the servo, sitting on the servo, and that moves backwards and forwards. I can't hold it in the place. Moves backwards and forwards here and operates a microswitch across there. And I had the wire in one of these because we didn't get enough throw. What we have is that the wire ends up coming through that hole there and effectively is pivoted at the top because it's chamfered underneath. So the pivot is this top surface. And with my 4mm thick baseboard, which again you'll need to go back a few videos to understand why, that is not going to give me enough throw without going to the top of the servo mount, of the servo horn. Hugo, who is my 3D printing expert, has come up with a Mark II version, which we'll talk about in a minute. But first of all, I also had quite a lot of interest in would other people be able to buy these servo mounts after we've actually designed them? Will Hugo be able to print them for us? Well, that's not a good idea. And what Hugo has come up with is that the best way is for him to put them on Shapeways. That way anyone can go to Shapeways and buy the parts. He has to do a slight modification because they're not SLA 3D printed. They are, I think he said, laser sinter printed, which is a slightly different process but still produces very good quality. It's a different way of doing it, and it's faster apparently. So, to you people who would like to have one of these servo mounts or more, they will ultimately be available from Shapeways. As soon as we've finished the design, and there is another iteration to come yet, but as soon as we've finished the design, then I will post a link to where you can find it on Shapeways once it's been put up there, and you'll be able to buy them. I have no idea what they'll be charged at. That's entirely down to how much material it uses and well, it's not so much material, but to the volume size of it. Hugo's an expert on this. I know nothing about it. I did ask him to explain shapeways a little bit more to me, and he said it's actually quite complicated, and gave me the basics, which is what I've just given to you. So the answer is, anyway, yes, you will be able to buy this servo mount. What we have decided to do, and I have a Mark II version here, which I'll show you in a minute, and I have a Mark II version here which is actually sat underneath my point now. What you will be required to do, of course, is provide the other components. Obviously you have to provide a servo, and you will need some screws, and you will also need some wire. And you'll also need to drill out some of the holes. We're not going to try and make the holes a perfect fit for anything, because that's just not feasible. So we're going to make the holes undersized and let the user drill them out. So you will need a set of small drills. The smallest one you'll need is about 0.5 or 0.6 millimeters, and you'll have to go up to probably 2 millimeters. You won't need all sizes in between, but you'll need some of that. Also, the screws that you'll need for mounting the servo to the bracket, you use the screws provided with the servo, and these holes may have to be drilled out a little bit. We'll tell you about that later. To mount microswitches, you'll need 2mm, M2 by 10mm screws, and they just actually cut their own thread into there through the microswitch. And for mounting the cam that operates the microswitch, or should I now say switches, because we now have the ability to put more than one on, that screw there to mount the servo arm onto the cam is a 4.75mm long number 0 self-tapping screw. Now, I know what you're all going to say, where do we get those? Well, there is a company called modelfixings.com. I think I've got some, I have both of those screws here, and they come from, yep, modelfixings.com. Those are the 10mm screws, if you can see them in that plastic bag, and these are the number 0 by 4.75mm self-tapping screw, and they, as you can see, are, if you can see them, they are very tiny. You can buy them in 10s, but I buy them by the 100. I've been using these, so there's not 100 in there now, but 100 of those will cost you about 10 quid, and 100 of these I think is about 6. So as I said, you can buy them in 10s if you wish. I'll just put those back over there. But there will be some instructions available, whether you'll get those from Shapeways or whether I or Hugo will have a PDF that actually points out what you do. I don't know. We haven't worked that bit out yet. But there will be some work for you to do. It will not be a simple bolt together kit perfect. So there's a little bit of modelling for you to do on each one. The reason that we're not going to drill the holes for the wire out, for instance, which need to be clearance in most cases, is because people want to use different size wire. This has been designed to use 0.6mm piano wire, but I know some people will prefer to use thicker, and the whole point is the system will allow you to use thicker wire. It will just mean that some of the holes will have to be drilled differently. Anyway, let's have a look at the new Mark II version and compare it to the original that you saw, Mark I. Now, the first thing is we've got a modification to the cam. There was possibly a tendency for this cam to twist a little bit, and a lot of that was due to the fact that, and this is going to be really difficult for you to see, but that screw that goes into the cam, the hole that it's in is in a recess which is intended to be the same size as the rounded end of the servo horn. Now Hugo's decided that that's absolutely not necessary. So what he's done with the new one is he has made it a straight through connection. As you can see, it now goes straight through. It is tapered a little bit, I think. Yes, it looks tapered a little bit. So it will still hold tightly onto the servo horn. But one of the big problems that we had, and we don't know whether we can completely cure it, is that when you screw the self-tapping screw into this tiny hole here, it throws up burrs. It pulls material out, as self-tapping screws do. And what that causes is it causes the servo horn to sit, I'm exaggerating it by a lot here, but it causes the servo horn to sit at a funny angle. Can I do it better that way up? And you can just about see it there. This is not flat to the servo horn. And the reason it's not flat on the first one is because it's really difficult to get a file or anything in there to clean it up. But with a straight through, then with a small file, having put the screw in once, you can take it out, you can take all of that burr off, and then you can screw it back in again to a flat surface. Now, there is a modification that Hugo is also doing on that to put a slight recess in the top of the hole, which means that there is somewhere for some of that swarf that is going to be thrown out to go. But it probably won't take all of the swarf, because we don't want to go too deeply into it, because it is quite a short screw. So that's one modification. There is another modification to this where this has been made a bit stronger, so there's no way it can bend in this direction as the Microswitch pushes on it. Don't think that ever happened, but it's just an improvement. As far as the rest of the mount is concerned, then there are some significant differences. The first one you'll notice is that this is the Mark 1, this is the Mark 2. Instead of there being a hole there for the pivot point, we now have a slot. So that does nothing to pivot the wire. And we used to have the pivot point right at the top here. What we have now, if we turn them both over, I'll try and keep them the same way round. This is Mark 1, this is Mark 2. What we now have, harder to hold them like that, what we now have is this has been extended downwards, and we have 2 rows of holes here. And the slot goes right to the bottom of that extension. These 2 rows of holes allow you to put pieces of piano wire in. They should just push in if you drill the hole out right, but you can always put the tiniest bit of sino on to hold them. There's no pulling them out, but a little bit of vibration, they could drop out in that direction. And indeed that happened to one on here, because I couldn't get it to work this morning and realised we'd lost one of the wires that we'd poked in the holes last night. So there's an adjustment now as to where the fulcrum is, and Hugo's actually going to extend this. I don't know how far, but at the moment we've got about 7mm of adjustment. I reckon we could get nearer 10, but whether that will be 10 or 9 or 8.5, I don't know. But these are some of the holes you're going to have to drill out to suit your piano wire, so that you can choose your pivot point. And once you've chosen your pivot point for your thickness of baseboard, then you're not ever going to need to change it. So you will be able to build all your servo mounts to the same. So that is a major modification which greatly helps to increase the throw in my very thin baseboards. If you've got a thick baseboard, you'll probably be right at the top. But in my baseboard, it's very thin. The reason it's very thin, you will find in my previous video on working with Styrofoam baseboards, which I haven't actually shown you any working on them yet, but this is all the preliminary to making my new piece of layout, which will be entirely based on Styrofoam baseboards. And as I say, I'll try and put a link to that video, the previous one of these videos, in the description, or actually I'll put it as a suggested video at the end. So, are there any other modifications? Well, yes. This version had one microswitch fixing point here. Now, to me, that was plenty, because I only want one microswitch. If I wanted two, for the very rare occasions, I'd be happy to make that microswitch drive a relay and get two contacts. So that wouldn't bother me. But there are some people that always want two microswitches, and some people that might even want more. So what Hugo has done in this version is we've got the standard microswitch here, which operates at the 0 degree point of the travel, and we have a microswitch here which operates on the same cam at the 45 degree in this direction, and we have a microswitch that mounts here which operates on the 45 degree position in this direction. If you're not using the full 45 degrees, then those microswitches may not operate, but there are times when you need the microswitch to be able to operate right around there, and this is what we've come up with as another solution to the people who want more microswitches. If you want multiple microswitches in the centre of travel, then maybe this servo mount won't be for you. But there are plenty of other servo mounts that you can try, but all of them require lots of adjustment. The whole crux of this is, we started out by me saying I want to be able to avoid adjusting anything for my situation. I want to be able to build it, test it with the servo tester, put it on the layout, and know that if I set my servo up to go plus and minus 45 degrees from my servo driver, which is likely to be a megapoints driver, then I know that my points will work and my switch will happen in the right place. That was my brief, and also to get the whole thing to fit within the width of 00 track, which it does. So Hugo has aced most of my requirements. We just did mention that another microswitch might be a good idea, and he added two more. So they are the modifications. There's one other thing that we're going to have, and that is a template which will also be 3D printed, which will simply have, it'll look a bit like that, and have a hole in the centre and two holes there, but it won't be this shape. It will be wider. It'll be wider than the track, and you'll be able to sit it on the baseboard. So let me pick that up. I can't seem to do this and keep my hands out of the way. Okay, it will sit, you'll be able to sit it on the baseboard over, if I can get it to go over that. The point won't be there, of course. This is before you fit the point. You'll be able to fit it over the wire, with the wire just coming through a hole that's exactly the right size for it, the first one that you drill, that is in the centre of the point travel. And then, with that determining that position, you will then line up two slots in it with the rails, so that you know that it's all perpendicular to the track. Having lined those up, you then drill your holes, or mark your holes through it for the mounting screws. That way it's very easy to mount, and you can do all that from the top of the baseboard. The only thing is you have to stop the wire from falling out of the bottom while you're doing it. But if the hole is drilled 0.5 millimetre, then if you push 0.6 in, it's going to be pretty tight. In fact, a 0.6 millimetre drill will probably make it pretty tight. So that is what we're going to do, and that's what hopefully will ultimately end up on Shapeways for anybody to buy. I'm not going to make any money out of this, and Hugo, if there is any money to be made, is going to take that. But that's fine, because he's done the lion's share of the work. I just want something that's going to work for me on my styrofoam baseboards, and up until now I haven't found anything that is suitable. There is something already on Shapeways that is similar to this, but doesn't have any microswitch mounts. It is just something to screw a servo to, so that you can put it on the baseboard. It's probably inspired by Dave Fenton's videos with the mega points, and using mega points to operate relays rather than having microswitches at all. That's okay, but relays are quite expensive. Microswitches are relatively cheap, so that's why I decided to go for a microswitch rather than a relay for each point. Okay then, let's have a look at this working. At the moment it's in the centre, and what you can see, I'm just looking at it, what you can see, if I turn it over it's probably easier, is that the servo horn at 1.5 milliseconds, which is the pulse width, is not quite vertical to the servo. That's because these single-ended horns don't line up properly in this direction. If you turn them round so they're that way round, so they point down this way, they line up perfectly. But going in that direction they don't line up in the centre. Now that's not a problem to anybody who's going to do adjustments, but it is a problem to me who's not going to do an adjustment. So that's the first thing you'll find. Right, if I just, well, I'll operate it first. As you can see, I am using the top two holes. You can just see a wire sticking out of this one. There is a wire in that one, but it's quite short and it's gone right in. But as I now let this move, now it's going more than the 45 degrees. So what I'm going to do is I'm going to make it go 45 degrees. So if I just put it there, that is 1 millisecond, and we're just over 45 degrees from where we started, and we started slightly in that direction. And this is the other end, which is the 2 millisecond point, nearly there. Oops, too far, beg your pardon. That's the 2 millisecond point, and we're not quite far enough that end. So you can see we're offset a little in that direction due to the fact the servo horn wasn't in the right place to start with. But with that amount of movement, if I turn this over now, you can see that we are, get that hand in the way, we are pushing solid against that. There's no more movement there. That is definitely holding that rail against there, and that hasn't gone quite far enough. And if we go the other way and go back to 1 millisecond, which we're pretty much at now, you can see we've got a little bit more spring tension, and we're holding solidly against that stop rail, and we're using the wire to do that for us. But what you also notice is there's no servo chatter. And there's no servo chatter. I've not stopped the drive. The drive is still there. But there's no servo chatter because the servo has got a spring to work against. So therefore it can get to the end and stop. And this is something you find is much more difficult if you use 1 millimeter piano wire. Without that spring in the wire, and the short length of 1 millimeter piano wire does not bend, not easily. And without that spring, what happens is the servos chatter. You can turn the drive to them off, but you can't do that with digital servos. But I don't use digital servos, so I'm no expert. Anyway, so you can see that with no adjustment, and the microswitch operates as we said. There is a microswitch on there. I turn it round like that. You can see that there is a microswitch on there. Excuse my head keep bobbing into here, but I'm having trouble getting this in the middle of the camera and keeping my head out of the way at the same time. We can, the microswitch is operating now. There it is. There it is. It's operating round about there, which is at the centre of the travel, which is really good. So Mark 2 is a definite improvement on Mark 1, and is a little more commercial. As I say, the Mark 3 version, which is going to be the commercial one, is going to have a slight modification here to allow you to be able to have a thicker baseboard, and a couple of other little things. As we said, I've lost it. There it is. The cam for operating the microswitches is going to get it the right way around. Is going to have a little indentation, a little chamfer on the top of that hole, so that it tends to sit flatter. And we're going to also have a mounting template, a drilling template, which you won't. I don't think it's going to be one per mount. It might be, so that if you order a mount, you automatically get a plate. But it may just be a separate item that you can just order one or two of if you want 20 or 30 servo mounts. So that's where we are with that. I hope you enjoyed the video. I hope the people who don't want any more JMRI now realise that I am going to continue doing modelling as well, and don't just abandon the channel, because the JMRI won't be forever. I haven't got any more JMRI videos yet sorted out yet. The next one I'm going to do is going to be an installation guide, where you get the files from, what you need, how you get started with JMRI, and also what you need to connect it to your DCC system. Now it's not going to be a comprehensive what you need to connect it to your DCC system, because every DCC system is different and I don't know all of them. But for instance, a lot of them have got USB ports built in, and a lot of those are already available for JMRI to connect directly to. If you're a Merg C-Bus user, then JMRI can also connect directly to Merg C-Bus via the USB 4, I think it is, which is the C-Bus to USB connector. So there are ways of connecting JMRI to most systems, but we'll go into that in that video. Although I shall only show you exactly how you do it on an NCE power cab, because that works for pretty much any low cost budget NCE system. If you've got an NCE Power Pro, then I'm not sure. It used to be serial port, which is, of course is a problem for modern computers because they don't have one. But anyway, I'm not going to go in waffling on any more about JMRI. That will be for the next video on JMRI, which may be the next video that comes up, or there may be something else in between. So until then, I'll say goodbye and thanks for watching. Bye.